Let's do this. Let's watch this and analyze everything.
This is how intelligence is made.
Yes.
A new kind of factory.
I usually watch these off stream, but
generator of tokens.
There's a lot to talk about with
The
this
building
one.
blocks of AI.
AI.
Tokens have opened a new frontier, the first step into an extraordinary world.
Meta-humans.
Where endless possibilities are born.
That's Takio? What?
Tokens transform words into knowledge and breathe life into images.
These on. Whoa! Wow,
they turn ideas into videos.
Oops. Wait. Now hold on a second. So it takes the picture,
breathe life into images,
and then it just shifts things.
Into videos.
AI for you, man. AI.
And help us safely navigate any environment.
E-I-E-I-O.
Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Tony, light up.
Now, I don't see this being our future. I really don't see this being, because the amount of money it takes to get these robots up and running and then maintain them also. If you have some drunk that is sitting there that's fuck you, robot, I want another drink, you know, and then somebody punches the freaking robot, that's going to cost a lot more than just somebody being like, okay, buddy, you've had enough, and then, you know, and being able to dodge or something, you know, somebody throws something at it or whatever. This is the reason why I'm like, robots, they're cool. They're cool to think about. But I don't see it being like, actually, this reminds me of a game that I played a long time ago, and I brought it up there last stream, called Detroit Become Human. And it is 100% one of those things of, I really need to go back and play Detroit Become Human again, because I am seeing these robots and shit that is mirroring what Detroit Become Human was talking about so drastically, and it's kind of funny seeing it. But yeah, anyways. 1 minute. I got 1 minute in and I started pausing.
And give us
it's going to take forever tonight.
When we need it most.
Hi, Maroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
I feel like that would just scare the shit out of me. If I was younger, I'm going to be here. Hell no. That's freaky. It sounds weird. No.
They bring meaning to numbers.
Okay, this right here is a prime example of good AI. This is proper use of AI. I think if we use it to do number crunching and stuff that would take other people, you know, an hour to do, and you can do it smacking shit out of the microphone. You know, if it's going to take somebody an hour to crunch the numbers and a computer can just do it instantly, no problem. I'll just by awesome. Also bringing things to life like that picture, you know, like they did with the 3D effect with the picture. Awesome. I love that stuff. Making robots with it. It's a cool thing in concept, but I just don't see that applicable. Not like worldwide or whatever.
Help us better understand the world around us.
Like, this is awesome seeing that. Weather patterns and everything. If you can literally make an AI model and predict, you know, where a hurricane is going, and you can evacuate people, it's literally the Twister story, you know, of like, oh, you know, there's a hurricane that's going to, or a Twister or whatever that's going to touch down over here. Be careful of Florida and all that stuff. Literally, this was the big storm that happened, and I flew through this through cloud coverage and all that stuff on Flight Sim 2020. So yeah, like just, and if anything like that happens again, hopefully not, but you know, if there is a big giant storm, something, I would love to see what the more up to date version in 2024 Flight Sim, what that would actually look like, if there is extra storm tracking capabilities and everything else that the AI can do with the more upgrade stuff.
Predict the dangers that surround us.
Also, I know I'm pausing every 2 seconds, but if you look down here, you can see what each of these AI systems are called.
And find cures for the threats within us.
They're going to cure cancer using AI.
Tokens can bring our
Ew. Okay. Yeah. I'm
I got my voice back, buddy.
They help us move forward. One small step at a time.
This is literally that Dark Souls like one there where the guy's in the wheelchair and then they strap a exoskeleton to him and he's like, I can run around now. And then the robots try and kill him. But yeah, it's literally that. I always forget what it's called.
And one giant leap. Together.
Reapers are coming. Oh shit. Yeah, this is the stuff that Elon is working with NVIDIA with too.
Is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Jensen.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object, well, just get used to it. I really think you have to let this sink in.
A snake skins.
In another hour or so, you're going to feel good about it.
Okay. Looks like snake skins.
Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA. You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
With NV1, we wanted to build computers that could do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA.
Yes.
Missing the letter C until a little while later, but UDA, Unified Device Architecture. Yep. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible.
There's the 4080.
Now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible.
Okay, so they released a full video of this. And I'm going to interject the video. It's a 35-second clip. This looks insane. Not to be that guy, but if you look at his, like the feet have movement on it. Like his feet are digging into the ground. Dude, it's got Tekken fucking slow-mo moments. He's standing there in a bathrobe. It looks great. I'm wondering what is the input's going to be like on that. So this is what I've been waiting all day to actually do. Wait, not actual gameplay. Gotcha. Okay, it says on the bottom. It says on the bottom right down here of not actual gameplay. Gotcha. All right, so this is their game. Let's see here, pre-development in-engine footage. So this is their engine. So this is what the game will look like, but this is not actually like. This is just the CPU running two characters. Basically, it's CPU versus CPU, pretty much. So the number one thing to remember on this is every time. So normally what you would end up having is the, you block, you have an animation for block, and then you go into a punch, and that is the, is 1 1 2 1 or something. So what I actually want to do is look at this with that in mind. How many button presses would this be? So possibly one to do a back kick like that. I mean, we know this is not in this, so this would be closest thing to gameplay here. So let's see here. How many button presses are we looking at here? One. Okay. Again, low block is literally bringing up the knee and blocking with your shin the kick. A high block could possibly be, doing the. That's crazy. If it can literally map out, because then you're talking hitbox only like the size of your shin, hitbox only the size of your fist. Like, what? Instead of your whole character being a hitbox, as it normally is. That is so much more computing processing power that you got to do right there. There was a dot on the screen that wasn't supposed to be there. Right in the middle, there was a dot or something, or was that boom, boom, boom? Yeah, it was right there. I'm like wondering, okay, so a lot of what is this mocapped or could this be like AI generated animations? Somehow they AI generate the animations to run on this. AI, it's a tool set. You can use it in a bunch of different ways and whatnot. I am, in all honesty, though, from what I've seen from AI, I don't think I would want AI generated animations. I would want mocap still because of the fact that AI screws up so much. I think I would still want to see just mocapped, and also just like the kooky funny stuff that you can do when you have the mocap suits and everything. I think I'd much rather still have that. All right, let's get back to NVIDIA.
6 years after that, 6 years after 1999,
right,
we invented CUDA.
CUDA core.
So that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it.
CUDA core processors.
CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Kershevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history.
I heard about a lot of this stuff, but I didn't jump fully into it because I was just like, wait, AI, that's just the CPU of what to see. Because I've heard of AI since 90, yeah, pretty much like what he was talking about there. Like I've heard about this AI stuff since like 94 or 5 or whatever. That was like, oh, we called it CPU, but it's the same thing as AI stuff essentially.
AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI.
Chairs fall
can
apart.
generate images and text and sounds.
Right.
And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI.
Okay, I'm going to, again, I am going to skip through some of this because I don't want to spend all night on this.
What modality of information did it translate to? And what modality of information is it generating? If you ask these 3 fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well,
I will say this right now. Again, I think I've said it before on video. I definitely said it on social media before, but AI is essentially like, it's a tool set like the internet where you can literally use it in everything. It's just how you use it. It's how you implement. And the same thing with the internet, the way the internet has transformed every single device that we have, everything is connected to the web now. I think that's going to be, in one form or another, you're going to have one small little form of AI in everything going forward, just because it makes computing processes that much easier to do. And if we can get to a cheap, to a cheap state of being able to program stuff using AI, I mean, you don't need AI for everything, of course. That's not what I'm saying, but it can be used on everything. It doesn't need to be, and I think that's going to be we're gonna have one of these like AI has to be in everything. I'm getting sick of hearing about it, and maybe it's kind of cool again. We're gonna have one of those up and down roller coaster rides with it.
GPUs.
We always do.
GeForce, in a lot of ways. All of this with AI is the house that GeForce built.
Yes.
GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
Final footage is rendered in real time using RTX Blackwell. Really quick before we get too far into this, if you remember the other night when I was playing tech and I'm like, imagine if they used AI to render like the flame in the background on the stage, if they use AI to simulate cloth physics and all that stuff. Imagine how much more if you take the burden off from the rendering power of everything and it goes into the AI computing system, how much more you can do on screen at once and how much more detail you can throw on there and all that stuff. I think this is where we're going with it. I think I actually nailed it right on the head without actually even, like, it was just kind of one of those thoughts that popped in my head of like, damn, why can't we just use AI to simulate? Because, you see all of this AI filtering that I started saying AI might be the future of game tech when I saw the rendering in real time over the top of like Red Dead, and it doesn't work super well right now though. That's my only issue with this. Like, if I think we still need a couple years of development on this, like R&D and everything. Anyways, let's just. I'm gonna say probably half of the stuff in this scene, if they are doing what I was saying, might be rendered using AI. Or is this... Okay, so DLSS 4, full ray tracing on, RTX is on, we're getting 150 FPS, which we can't even see that on YouTube or anything anyways, because this video is literally rendered, the live stream is rendered in 60 FPS. They might be able to see it in the... why is it custom? Oops, no. Normal. There we go. What? Normal. Oh, YouTube did a weird thing. Okay. So this might be what was my thing? Oh yeah, DLSS 4.0. We got to talk about this because I actually might have an issue with DLSS 4. But 150 FPS, you can't even see that on YouTube at all. The most you can see on YouTube is like 120 FPS, I do believe, and unless you have, you know, like the native video right in front of you, download off their website or something, which I don't think they have hosted, there's no way of actually seeing how good this looks, like how smooth the video is. So it's just keep that in mind. I would say the ray trace lighting and reflections. Neural material, 16 megabytes of memory? 47 megabytes versus 16. Okay, so basically what this is it's increasing the pixel count on everything. So this is like a, 47 megabytes of memory, probably, I don't know, an 8K image versus a, 1440p. So pixel count is like doubled or tripled on this image than this one over here, which makes it so you can have more shininess, you can have more, all the rips and tears and everything, or not rips and tears, but the creases and everything that you can see in there. Yeah, I mean, it looks great. It says Transformer. Yeah, the lighting. Hold on 1 second. Okay, so we have light rays coming in. We have the lighting in the background that is doing one form of lighting. We have this lighting here that is not really doing too much of a bleed effect into the background, into the shadows and everything, but different light sources happening all at once, and nothing is like blending or blurring together. It's pretty good. That's pretty good. Neural faces. Still looks like graphics. Not exact. It's full realistic with the game character look to the, what do you call it? Like the material that makes up the skin doesn't. We can do it with metahumans and stuff. We can actually make it so, but that's Unreal Engine. That's not NVIDIA. That's the reason why we need these companies to be working together, because with Unreal Engine mixed with all this AI stuff, I mean, shit, you could probably make something that does look full realistic with the metahuman stuff. If you layer an AI face filtery type of situation or a job or whatever, you could essentially make your characters look lifelike. We could literally have a game. It is possible, even right now. It would look like shit right now, but in the next next gen graphics, the possibility is there that next gen graphics will actually be like you're playing a movie, and I mean that in like visual live action version of the game. Like you are controlling a live action character on the screen instead of looking like a game character like this. My only thing with that is like, okay, so photorealism is an art style. This is an art style. I don't think anybody should be putting down one or the other. I think it's just different styles of what the creators are going for. So anyways.
That was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did.
Yeah.
We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render.
Bingo. And that's exactly, like I said, like use AI to render out different things that are in the environment and whatnot. Like, why wouldn't you do that? And there you go.
Not only can we do that, it's called DLSS.
Yep.
The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate.
Okay, I have a problem with this now. We already are doing this, but it's called ghost frames that ends up generating. And the ghost frames adds in kind of a weird blur effect, and they are not active frames, so then you end up having latency on the controls and whatnot. So for gaming, if you're making a CGI movie, whatever, this is amazing. If you're trying to do games, design where it's like you need every active frame, like say you're trying to make a Dark Souls game and you're trying to use DLSS 4 on the where you need every single split second counts of when you're hitting that button press, you could hit the button press in one of those ghost frames and it's not an active frame. You just missed your input. You're online and you have ghost frames and you have a latency discrepancy error in the latency of, because you have one person with a bad connection on that. You're going to have ghost frames. You're not going to have active frames. You're going to miss your input. This is my only gripe with this DLSS 3.0 and 4.0 is that the ghost frames maybe somehow make them an active frame. I don't know, but the latency issue.
What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders,
okay,
our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33.
What if you just render the outline? So, what the hell what's the actual name of it? The gray box outline of the world and the characters. What if we render that and then we use AI to generate all the coloring and everything else? So the AI has samples of the textures that it's supposed to be rendering. And instead of rendering all the textures in game on the fly, we have AI throw the textures where they need to go. I wonder if that would be more expensive to render, or if it would save up room so you can render more stuff on screen at once. This is the stuff I have no idea when it comes to AI stuff, when it comes to that stuff, because it's like, this is where if I was the head of a studio, I'd be asking the question to the other people who are way more expert in this of like, can you guys figure out this? Can we try this? Can we R&D this? And which way is the better way of going about this? Because there's a tool set there that, again, what AI is going to do is it's going to make people be able to start thinking outside the box the same way that we could start doing when we went from the polygons to the God, it's not well. I'm trying. I keep trying to remember because there was. So this is like back in the days when I wasn't super following everything. I know that we had polygon counts way back. That's what we started with. Where you had block characters that were made out of so many polygons, and then you had the next era, which were, I think it's more polygons, but I'm pretty. There was another word. I can't think what the hell the other word is called. But it was, it was the evolution of game graphics where we started getting more 3D effects going on and everything.
And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
Welcome to the 50 series graphics card. Imagine the size of the damn thing in a computer. This thing is gonna be huge. Okay, double flow through. So we got 2 fans, 3D vapor chamber, high density PCB board. Yeah. So here's the funny part about your graphics card. The chip is in here that you're actually using. This is all computational. Oops. And then 90% of what you're purchasing really is the chassis and the fan support and everything to keep the damn thing from cooking itself, from overheating. Thermal pads. Wait, was that thermal pads or was that memory? I just totally blanked out. I was trying to think. Okay, so 92 billion transistors, 4,000 AI tops, ray trace teraflops. Okay. I like how they're using the transformer sounds.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 tops, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can.
I know this is really good, but I don't know exactly how good unless I see it in action on the screen. It's one of those things where it's like, in my brain, I'm just like, okay, I know these numbers are high, but I don't know how this translates to on the video on the screen. That's my only my problem with all this stuff is like, that's the reason why I don't usually stream reactions of the CES stuff, because it's just like, okay, I know that's really good, and I'm pretty sure that's like the top line in the market, but I don't, like, show me a video of this thing rendering all the rays and the tracing and everything, like, and then I can really pick it apart.
And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer.
Okay.
G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks And as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results.
Again, okay, yeah. So it's the same thing as what I was saying with the fire of, okay, here's how fire is supposed to look. Let's render this in the background. There's supposed to be fire over here, supposed to be fire over there. You're on fire now. Well, fire would, conform to this object, whatever. That's the 3D object in the space. And the fire would do the thing, it would say somebody gets lit on fire from the feet up. And it would, the fire would in real time be able to compute and conform to the 3D object. And then all of a sudden the object is on fire. Maybe don't say that. Maybe I won't say from the feet up. If you're trying to light a house on fire, that's still just bad. Actually, lighting a house on fire would be a very good example because then it could also, back on the PS3, if you played Alone in the Dark on the PS3, there was a whole thing. This is what actually everybody's like, that game fucking sucks. I'm like, there's actually really cool tech demo in there because the fire would spread. And Far Cry end up using this later on also, where the fire, you light one thing on fire and then all of a sudden, and it just spreads out across the mountainside. You can light the whole damn, the whole grass side of the field, whatever, on fire and all that. So essentially what AI is doing is it's doing that, but, same thing as a fire effect that we've had for years, but it's doing with laying now. It's doing with shading. It's making shadows actually work the correct way. So then you're going to, and this is the thing, shading and laying, does it go a long ways of making, if you light, like you can see actually, you can see the light bouncing off from the forehead. You can see it bouncing, reflecting, I should say, off from his jacket because the jacket is a certain type of material. He's kind of sweating up on stage a little bit. So you can tell it. There's more detail that your eyes are picking up.
Okay, so this is the brand new RTX Blackwell 5090.
Very cool.
Now, even the mechanical design is a miracle. Look at this. It's got two fans. This whole graphics card is just one giant fan. So the question is, where's the graphics card? Is it literally this big? The voltage regulator design is state-of-the-art, incredible design.
How much electricity? How much wattage are we talking about? When are we going to need like a 1200 watt power supply to be able to run the fans and the card or and the chip itself and everything? Electric bill going up.
The engineering team did a great job. So here it is. Thank you.
What's the wattage on it? I'm really curious. Does it say? Nah, it doesn't say in there.
Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right?
No.
Don't tell me that's not true.
No.
Don't be ashamed.
No.
It's liquid cooled. Fancy lights all over it.
RGB.
You lock it when you leave.
Right?
It's
cage
the modern
around
home theater. It makes perfect sense. And now for $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
I'm just going to say this right now. Trump's economy. Bam. Bam.
Impossible without artificial intelligence. Impossible without the 4 tops, 4
For that GPU is 200, almost $200. So that's fucking what, 150 whatever. It's math. It's cheaper than the PS5 Pro, and you could essentially fit into the budget on a brand new PC build. They're getting there. The PC side of things is getting there towards the console market of like, hey, you could build something that can rival this shit. Now, PlayStation also has PSSR, so DLSS so far has still been the shining beacon when it comes to render upscaling and everything. So DLSS, what this card can do is DLSS. What the PlayStation can do is PSSR. PSSR is very good. It's very worth the money. That's a pretty good price tag. That's a pretty good price point for that. It's probably going to sell the fuck out. Like
AI
instantly, it's going to
tensor
sell
cores.
out.
Impossible without the G7 memories. Okay, so 5070.
It's gonna
4090
get
performance,
scalped as shit back.
$549, and here's the whole family, starting from 5070 all the way up to 59.
Again, that's pretty good. That's a pretty good price point for all that. I mean, $2,000. Oof, that's a price of a brand new rig overall of what I would build. Because every time I try and build a rig, it basically hold up 1 second. Hold up. Bullshit. Oh. Stupid ass green screen. It's such a pain in the ass using a green screen, but it works way better. This is why AI needs to do its thing with the background removal, because AI doesn't work as good with the background removal. Green screen works better. I got fucking Tekken on the brain and it won't go away. Leave me alone, Tekken. Wait, what? S-Fan is live from CES? Don't you do this to me. I need to watch the press conference. I might start fast forwarding through the press conference a little bit though, not gonna lie. Ow. My head. Okay.
5090, twice the performance of a 4090.
Oh, that's so to finish the thought off. Yeah, every time I build a PC, right now I've been using 30s series Okay, when I say building a PC, I mean on the website. I haven't. It's like not physically, but on the website when I'm like trying to do price checks on those stuff because I need to upgrade my PC sometime in the future here. It comes out to roughly $2,100, and I'm like, ugh, can I get it underneath? Like right now, because I already have a case from an old build, I could end up using my Samsung the SSD hard drives I already have. And then also the hard drive, basically add my gaming rig that you're seeing now. Like half of those parts, I could literally upgrade my computer for about just over $1,000. So this is, in all honesty, this is probably gonna be overkill. 5090, usually the top of the line thing. You use that for rendering projects, not gaming really. Normally the $1,000 one is, or maybe actually, I would probably say 18. Well, it's hard to say. It's hard to say because so as of right here, I would probably just go to 57 Ti, and 70 Ti, 1400 AI tops. I mean 750 is still. Or would I just go to 57? Actually, because I ball on a budget, I'd probably just go to 550 and go to the lowest one. Now, it all depends on what this card is capable of. So, what you might end up running into in the future is I guaranteed 5090 is going to be for like work rig. It's like if you're trying to stream, photo edits, do 8K videos in the future. Nobody's going to do 8K videos in the future. 4K videos, we'll say. All that stuff you want to get the 4K rendering done and uploaded real quick. Boom. That's the 5090 is going to be like probably overkill still. Probably just go to 5080 with that because that's the thing with all these cards over and over and over again. Every single year, we always, oh my God, everybody's ass is blown out of their seats and everything with all these numbers and all that stuff. But when you actually put it into practice, you usually end up sticking around the 57 Ti to like a 5070 over here, like this lower end price point, just because it actually makes sense. Right. So, and this is the other thing. If you're looking at this from a gaming standpoint, we are pretty much topping out the game engines and what the hell they're capable of. And I don't see we're going to need a ton of computational power in the future if we try and go the full realistic route with stuff. I don't think we're going to need a shit ton of power to do that, of system resources, because I think AI is going to end up as in the next few years. I think AI is going to actually compile things a lot better, and you're just going to have a lot less resources that you're using. So when it comes to like VRAM and everything, my prediction is we're going to probably see games it's going to be a better usage of the VRAM. Instead of more VRAM, it's going to compile things a lot better, and it's going to compress things probably. I guess I think I'm using that word the right way. I know compiling is a major thing. No, I'm not a programmer. I've never worked in a game development studio. I've just heard a lot about this. I usually have my nose stuck up everybody's butts when it comes to game development and everything. Of like, how does this thing work? Because I need to know that to make the game engines work the proper way. Of like, okay, what does this do? What does that do? What does this do? I don't know the programming behind it though. I'm not a programmer. I'm not a coder. I can make mods work. I can make the game engines, dance the way I want them to and everything. I can make the frame rates go really good. And that's where I'm coming at this from, of like, okay, so how do these cards stack up to one another in that area? If I was to build a PC, if I really had a big budget, I would go with a 5070 Ti. If I was kind of more on a budget, that $500 or $550 for a 5070 looks great. It looks great. That's probably the way I would end up going about it. Let's see. And these next slides that they're going to show of like this card next to this card.
Well,
this is all marketing.
It is incredible, but we managed to put.
Let's see. Are they going? Okay, laptops.
This 5070 laptop has a 4090 performance. I think there's
12 or 1300 for for a full-on laptop build, that's not bad at all. 49 performance, half the power draw. So half the power draw. Yeah, I mean, again, if that is the case, so usually, okay, if they can do half a power draw, if that's where they're going at, let's
One
keep
here
it going.
somewhere.
Keep it going.
Let me show you this.
Are you going to actually run
This
Alan
is a-
Wake?
Look at this
No,
thing.
you're not.
Here, here. There's only so many pockets. Ladies and gentlemen, Janine Paul.
You need more pockets.
So can you imagine? You got this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense?
Yes, because this is why it makes sense. Because that graphics card, it's just like he just said. 90% of this is just a case. It's literally just a chip in the middle right there. So you got the two big ass fans. Well, if you do a liquid cooling system in this of some kind, whether it's liquid metal or something else like that, and if this does half the power draw, then it's going to be half the heat. So you can end up fitting this way easier inside of a laptop. That actually would mean that the laptops are going to run that more efficient with an NVIDIA chipset. So really, if you're going for a laptop, I would go for an NVIDIA chipset because then it's going to be kind of less power draw because the fans have to run less because it's half, again, that half power draw goes into it doesn't heat up. And if it doesn't heat up, it can go full clock speed. If it heats up too much, the clock speed will downshift because it doesn't, chipsets do not allow themselves to cook themselves. I'm selling myself on this chip right now. Holy shit.
Well, we're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have.
But so what is the power draw on AI? Because all I keep hearing about is AI that's the main issue with AI right now is it's a giant power draw. So would that heat up the chip? Because it's a give and take on everything. It's a balance on everything. I don't know.
As a result, the energy efficiency is just off the charts. The future of computer graphics is neural
Maybe
rendering,
okay.
the fusion of artificial intelligence and computer graphics. And what's really amazing,
I don't see how the chip can run at full speed and not heat up though.
Oh, here we go. Thank you.
If it's computing so much,
This is a surprisingly kinetic keynote. and
if it can,
what's really
awesome.
amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family.
I'm not gonna lie, that was my biggest interest of this press conference. So I am going to okay. A lot of this next stuff is just marketing stuff. I think we're just going to skip over a lot of it. Test time, scaling, reasoning, post. Okay.
The second scaling law.
Now, the reason why I say this is a lot of marketing is because they don't usually ever show anything rendering in real time on this. You have to go over to like a Digital Foundry or something else like that to really be able to see, okay, what does the frame rate actually look on this? How much detail, how much pixels are we seeing on the screen? All that stuff is usually on the YouTuber side of things instead of them in the press conference.
Sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step.
It's funny that he didn't say it. Grok on X premium stuff and all that stuff. Elon he's building like a giant ass supercomputer for Grok and AI, technology and everything. So, whether you like or hate Elon, he is actually helping out with all this stuff. So,
step of pre-training to post-training to test time scaling.
Not to mention he has enough money to be able to build a giant supercomputer that can actually push the technology forward. So if he pushes his profits or his revenue, or whatever the hell you want to say, if he pushes his money into AI tech, and it actually, what you could end up seeing on the other end of that is if he works with NVIDIA on top of the supercomputer stuff that he's working on, then we get the better product in the long run because it helps them develop stuff. You know, if Elon can end up R&Ding stuff in the background that helps out with all the SpaceX stuff and all that, and the Tesla stuff and everything, and they can do a breakthrough in that area, transfer that coding over to the gaming side of things, which he's a big giant gamer. He was just live streaming earlier. It helps out both ways. Again, whether you love him or hate him, everybody usually ends up helping each other out in the long run, because then, oh, okay, well, you got this thing that you figured out. Okay, we got this thing that we figured out. Now we can combine them together and you can do something even crazier.
Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems.
Yes.
And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some,
these are all server bases.
Cloud service provider now have systems up and running.
Oh, cloud server. Okay.
We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations.
Did Jensen literally just go, ooh, shiny? It looked like he just got totally sidetracked by like, oh, that's kind of a cool one over there. Oh, sorry. Yeah, I'm in a press conference right now. Okay, so this one up here, Microsoft Azure in the top of the frame, that's partly the system. I mean, it's it's a system like that actually makes Microsoft Flight Sim run the way it does.
Liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world.
Right.
Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry...
Okay, so now he's just trying to sell you on AI, which is like, yes, you know, we kind of know that... The real Captain America shield. Oh, right? No.
Wait for it. Wait for it.
No.
I thought I was worthy. Apparently,
they should have had on the screen the back, you know, like it's ching, and then
Yonier didn't think I was worthy. All right, this is my show and tell. This is a show and tell. So,
is it real, or is that just
this right here?
No, that's
this
not
NVLink
real.
system. This is GB200 NVLink 72. It is 1.5 tons, 600,000 parts.
I can't tell if this is actually a real chip or if it's just a picture on a fancy looking ass board. And this is just I'm at my wheelhouse on this. What the hell? I have no idea if that's actually how big the chip is, or that is just a blown up scale model of like, here's what it is.
Basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost.
Yes.
But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these apps.
So essentially, a token is a data pack. So it's basically like pack files on a game in a game folder. That's the way my brain is.
Applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power.
Yes.
And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now, the goal of all of this
Are we
is
talking
so that we can
sales or
create
marketing,
one
or?
giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go. Sorry, guys. You see that? That's cool.
Nice. Yeah, it's a
Look at
disco
that.
ball.
Disco lights in here.
I just said that.
All right. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops.
Sandstorm
The
starts
world's
playing.
largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance.
Damn.
It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips.
That's crazy.
Okay, and we have 130 trillion transistors. And
You know the problem with that is there's so many people just going. I'm going to share that one. I'm calling everyone out that watches Reels or TikTok or any of that shit. I'm calling you out. I'm calling you out.
Total,
Calling you out right now.
592 CPU cores, whole bunch of networking.
Okay, so networking chip. It can do it. So basically, it can do networking, or it can do gaming, or it can do processing.
That's happening in
Cool.
the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. It's AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from.
Not gonna lie, I'm gonna skim through this to see if there's anything else. Gonna be a lot of AI talk, and it is cool, but I just what? Okay, what is this? Real quick.
Into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process is different. The way you work is different. So you would give them.
One AI goes, "Hello, good day, good sir." The other one goes, "Hey, bitch! Who trained the AI? Oh, fuck, I don't know. Who trained it? What up, bitch?" And then the AI just gets reported, and it's just like, "Sorry, this is what I got trained to say."
Examples of what the work product should look like. And they would try to generate it, and you would give it feedback. And then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say.
No racial
And we
profiling
even
in
give
the
them
workroom.
access to
Oh,
certain
no.
information.
Oh,
Okay,
no.
So that entire pipeline.
Okay, what else are we got here? AI PCs? Oh, no. What is this?
Okay, so AI was created in the cloud and for the cloud. AI is created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want.
Oh, that's weird. No, that's weird. It's man, I've heard a couple people, it's just like, okay, put your shoes in the worst possible human being situation that so you have, like, if you got somebody who knows how to use that technology right there, they can literally look at you and be like, track where they live. And then you can have stalker cases and stuff like that. It's every time I hear about the Meta glasses or whatever, I'm just like, oh no, that's just give me their information. And then all of a sudden, because you can just, if you type your name into a search engine, the information that pops up literally will be given to them in their glasses in real time. Or AI can like go and it can bring up a whole profile on you just as you're walking down the street, and somebody could literally case you of like, oh, this person looks like a rich person. Boom, fucking somebody come and steal your shit. This person might have $1,000 in their wallet or whatever. Those glasses are not a good idea. You got to think of worst case scenario with stuff, and then you build up from there. Ugh.
And so AI is perfect in the cloud. Was created in the cloud, is perfect in the cloud.
Right.
However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so
they can track you from work and at home.
If you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like...
Wait, wasn't there a Windows 93 or something? Like my brain is Windows, was it 93 or 94 or something like that? Windows 93. Hold on. I need to see the... Yeah, I remember this was my first Windows experience, is Windows 93. We're getting old. Wow. Windows 93. That's a throwback.
Like to have in the future your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D and generative APIs for language.
See, I feel like this is too much. You're working with it too much there, because AI doesn't. Wait.
AI accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases.
Go full screen with this shit. Go full screen with it right now.
Object permanence. Developers use NVIDIA Omniverse to build physics.
They don't want to go full screen because this doesn't look real.
Spatially accurate scenarios.
You can tell there's something off with it. Every time I see AI stuff, I'm just like, there's something a little... I just know game graphics because I've fucking grown up with it. So I'm like, no, that's not real.
Then output Omniverse renders into Cosmos, which...
Again, though, if you can take the outline render like and this is what I was talking about. This is literally what I was talking about the other night. It's like, this is animated of what my brain was thinking when I was playing Tekken. If you can take just the render background of this and then throw a photorealistic filter over top of it, fuck. There you go. That's your future. That's your next gen graphics right there. Imagine CGI movies with all this stuff. It would literally, you could make a CGI movie look like a live action film, but then all of these stupid ass adaptations where they can't do half of what happens in a game, like Resident Evil movies could actually be Resident Evil movies using this tech.
Generates photoreal, physically based synthetic data.
I mean, right, yeah, like that's exactly this. So literally all you'd have to do is develop the outline and AI could render everything else on the screen. Shit, you could make game. We could essentially, if depending on how long it takes it to train and everything, you could essentially get back to having games, instead of games coming out every 4 years, you could make it in 2. We could get back to that like release schedule of like, oh my God, there is a new, Capcom, let's say, they put out a Resident Evil in year 2030. They put out a new Devil May Cry year 2032. Then on mid 2033, they have a Monster Hunter and then another Resident Evil the next year afterwards. Like, we could possibly get back to that if depending on how long it takes to do all this. I'm not gonna lie either. Like, if I could, hmm, I have a lot of movie ideas in my head a lot of times, and I just have no fucking way of making them. That's the reason why I like making YouTube videos, not just live streaming games, but I do like making videos that are like documentary type of videos, and like the launch stream videos. I do love making those too, because I always have like, man, this is a cool idea for a movie. I would love to make it. I have no idea how the fuck to do it.
Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse.
Whoa, it just popped in the head of like, if you're doing mocap, instead of doing the very expensive mocap suits and everything, you could essentially take and just like outline the okay, so you still have to do face capture to get the motion and everything in there. But essentially you could just do the outline of the motion capture. And then instead of doing like it, instead of it taking years to try and build up. Okay, there's got to be a way of doing it so that environmental artists and everything don't get put out of work, but they just use AI as a tool set to make their work easier and faster, and so that they can actually get the ideas across in a better time frame, but also that they can even do more with their ideas. That's the perfect world setup. That AI doesn't take over this stuff, but it's a giant tool set just to make everybody's jobs a lot easier so they can do more. That's the future that I would love to see. That's where I would love to see this go.
Simulation to AI models.
I think if we did just start using this to like, just generate with AI, we would start to see a lot worse quality. We could see a lot of quantity coming out, like a lot more products, but it'd be a lot worse quality of products coming out. Just relying solely on AI. Like, we don't have to have an extreme on this.
Every possible future to help the model select the right path.
Okay. Autonomous vehicles, robotics. Okay, that's a lot of marketing stuff after that. Okay.